Hello, everybody. All right, so lesson 12.9, the final lesson in the third grade Go Math textbook. Our topic today is relate shapes, fractions, and area. And our essential question is, how can you divide shapes into parts with equal areas and write the area as a unit fraction of the whole? All right, so pattern blocks, color pencils, ruler could be useful. Connect. You can use what you know about combining and separating plane shapes to explore the relationship between fractions and area. Trace a hexagon pattern block. All right, so I have a hexagon block here. I'm going to trace it. Hexagon has 6 sides, right? Okay, so we've traced our hexagon. Divide your hexagon into 2 parts with equal area. Okay, well, let me get my straight edge. All right, so this area and this area is equal. So write the names of the new shapes. What did we make here? Well, 1, 2, 3, 4-sided figures with one pair of opposite sides that are parallel. So we made trapezoids. Part D, write the fraction that names each part of the whole you divided. And it says right below it, each part is half of the whole shape's area. So 1/2. What's the name of the whole area? If we put both of them together, it would be 2 out of 2 pieces. Number 1, explain how you know the 2 shapes have the same area. Okay, so my thinking on that is, I know that the shapes have the same area because they're identical, and both are half of the total shape. So when we put them together, it makes a whole hexagon. 2, predict what would happen if you divide the hexagon into 3 shapes with equal area. What fraction names the area of each part of the divided hexagon? What fraction names the whole area? So let's look at that. So they're saying take the hexagon and this time break it into 3 equal parts. Okay, so we have 3 equal parts. And what do we call those 3 equal parts? Each part would be 1/3. Each part is a rhombus. So if I split the hexagon into 3 equal parts, I'd have 3 rhombuses. Each rhombus is worth 1/3 of the total area. If I have all 3, it would be 3 out of 3 for the whole area. Okay, so Number 3. Show how you can divide the hexagon into 4 shapes with equal area. I drew my line up a little too high on this part. I should try again. All right, so we want to cut the hexagon exactly in half 2 ways. All right, so that's exactly half. And then we want to take half of the shape okay, so that's a little better. So we have 4 equal areas. Okay, so basically we just divide it into 4 parts by drawing a vertical line and a horizontal line, so that it cuts it in half exactly. So each part is 1/4, right? 1/4, 1/4, 1/4, 1/4. If we put all 4 pieces together, it would be 4/4. All right, how about this one? Page 540. The rectangle at the right is divided into 4 parts with equal area. Write the unit fraction that names each part of the divided whole. All right, so this is our whole, and I see 1, 2, 3, 4. 1/4. Each piece is 1/4. What is the area of each part? Just count the unit squares. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So each part is 5 square units. How many 1/4 parts does it take to make one whole? Well, to make this whole shape, how many of the 1/4 pieces do I need? I need 4. Is the shape of each of the 1/4 parts the same? Are they shaped exactly the same? No, they're not. Does the area of each of the 1/4 parts is the area of each of the 1/4 parts the same? Yeah. Explain how you know. So they do have the same area, because when I count them, each part, there's 5 square units. All right, how about this one? Draw a line to divide the rectangle below into 6 parts with equal area. Well, how do we know that? Well, let's see. How many total squares are there? 3, 6, 9, 12, 15, 18, 21, 24. There's 24 total squares, and we have to put them into 6 parts. So I'm going to take these 24 squares and divide them into 6 pieces. So 24 divided by 4. 6 times what is 24? 6, 12, 18, 24. 4. All right, so we want areas of 4. So they doesn't have to be the same as mine. They just have to have 4 square units in each part. Okay, 1, 2, 3, 4, 5, 6. I have 6 sets of 4 square units. Write the fraction that names each part of the divided whole. Each part would make up 1/6 of the whole. What's the area of each part? 1, 2, 3, 4. 4 square units. Each part is 1/6 of the whole shape's area. All right, divide the trapezoid into three parts with equal area. Write the names of the new shapes. Then write the fraction that names the area of each part of the whole. So we have this trapezoid, and they want us to divide it into 3 equal sections. Okay, well, I see 3 equal parts. So it's kind of a V, right? So write the names of the new shapes. Well, they're triangles. What's the fraction that names the area of each part of the whole? Well, that triangle is 1/3. So each triangle is 1/3. Okay, number 2. Draw lines to divide the shape into equal parts that show the fraction given. All right, so they want us to take this shape and make it into 6 equal pieces. Okay, so go ahead and divide it from top to bottom. Okay, so that's going to be 2 pieces, right? All right, there's 2. Now go the other corners. Take this corner to that corner, and then this corner to that opposite corner. Okay? And so we have 6 triangles. What is the fraction? 1/6. Okay? Each of these triangles is 1/6 of the whole hexagon. All right, we're going to take this shape and break it into 2 equal parts. So if we make it into 2 triangles, they would be equal. So we have 1/2 of each shape. Okay, 8 sections. Well, let's see. If we had 4 equal pieces, it's pretty close. So 1, 2, 3, 4 equal sections. And if we take those 4 sections and break them in half, or double them, that would give us 8. I might be a little high with my line, okay? But we're going to call each part 1/8. Draw lines to divide the shape into parts with equal area. Write the area of each part as a unit fraction. So we're going to take this shaded square and break it into 8 equal parts. Well, I think it's easiest if we find the total number of squares first. So there's 4 rows of 4. That's 16, right? So 16 total divided by 8 parts. 8 times what is 16? 8 times 2 is 16. So we want 8 parts of 2. Okay, there's 8 parts of 2. Then write the area of each part as a unit fraction. The area of each part as a unit fraction. 1/8 would name each part. All right, how about this one? We have 6 equal parts we want. So let's count up all our squares. 3, 6, 9, 12, 15, 18, 21, 24. Oh, we've done this one. 24 divided by 6 equals what? Is the same as 6 times what is 24? And that's 4. 6 times 4. So we need to, again, put them in groups of 4. All right, there's 2 groups of 4. 3 groups of 4. 4 groups of 4. And 6 groups of 4. All right, how about, and then each part would be 1/6. Number 7, we have 1 plus 3 is 4. 4 plus 3 is 7. 8, 9, 10, 11, 12. 12 square units divided by 4 parts. 4 times what is 12? 3. 4 times 3. So we need to put them in boxes of parts of 3. Oops. I'm going to go ahead and color these 3 in because I messed up. Okay. All right, so we have 4 groups of 3. So each part is 1/4. Right, number 8. If the area of 3 rhombuses is equal to the area of 1 hexagon, the area of how many rhombuses equals 4 hexagons? Well, hexagon equals 3 rhombuses. So if we have 4 hexagons, there's 3 rhombuses in each one, right? Well, I could go 3 plus 3 plus 3 plus 3, or 4 times 3. Okay, 4 times 3 is 12. So it would take 12. 4 hexagons times 3 rhombuses equals 12 rhombuses. And number 9, divide each shape into the number of equal parts shown. Then write the fraction that describes each part of a whole. All right, so 2 equal parts. All right. Each part is 1/2. 4 equal parts. 1/4. And 6 parts. Well, we can start with 2. So divide it exactly in half. And then roughly 3 equal sections. Each part is 1/6. So 2 parts, the fraction would be 1/2. If I break it into 4 equal parts, it would be 1/4 each part. 6 equal parts, each part would be 1/6. All right, number 10. Divide the hexagon into 6 equal parts. Divide the trapezoid into 3 equal parts. All right. So we know we can take the hexagon, divide it into 6 equal parts by connecting the corners, the opposite corners. All right. And we know we can make the same thing by making a V on that one. All right, so each part is 1/6, each part is 1/3. Which pattern block represents 1/6 of the whole area? Well, what are each of these? They're triangles, right? Triangle. Which pattern block represents 1/3 of the whole area? Triangle. All right. Alexis said the area of 1/3 of the trapezoid, so one triangle, is greater than the area of 1/6 of the hexagon, because 1/3 is greater than 1/6. Does her statement make sense? Well, let me show you on this one here, okay? So this shows the same thing, but just using pattern blocks. We see that this trapezoid is broken into 3 pieces, right? And there's a green triangle, so keep that in mind. So then, if we have the hexagon, and we break it into 6 equal parts, I seem to have misplaced that triangle. Well, it would be 6 triangles, right? Okay. I seem to have misplaced one of my triangles. Okay. So if each part of this hexagon is a triangle, aren't the areas of those 2 triangles the same? So how can this triangle in the trapezoid be greater than this triangle in the hexagon? They're not. So no, her statement doesn't make sense. Okay, 1/3 is not the same as, you can't compare 1/3 of this trapezoid with 1/6 of this hexagon. They're not the same size. The holes are not the same. Okay, so they're not the same size. If I had another triangle, then we would see that this would actually have 6 pieces. And so it would be 1/6 is equal to 1/6. So what could she have said? She could have said 1/3 the area of the trapezoid the triangle, right? 1/3 the area of the trapezoid is equal to 1/6 the area of the hexagon. Because the area of 1/6 of the hexagon is a triangle, 1/3 of the trapezoid is a triangle. So they have the same area as far as in relationship to the size of the triangles. All right, what if you divide the hexagon into 3 equal parts? Write a sentence that compares the area of each equal part of the hexagon to each equal part of the trapezoid. All right, so we know that they broke the the trapezoid into 3 equal parts. So it had 3 triangles. I know that I can also make a hexagon out of 3 rhombuses. Okay, so our question is, if we divide the hexagon into 3 equal parts, write a sentence that compares the area of each equal part of the hexagon to each equal part of the trapezoid. So it's asking us to compare the areas of these two things. Is 1/3 the area of the trapezoid less than, greater than, or equal to 1/3 the area of the hexagon? 1/3 of the trapezoid. 1/3 of the area of the trapezoid is less than 1/3 the area of the hexagon. Okay, so again, what is that last question asking us? It's saying, let's compare a trapezoid that's been broken into 3 parts versus a hexagon that's been broken into 6 parts, but we're only comparing each equal part. So we're basically comparing 1/3 of the trapezoid to a third of the hexagon. It's twice as big, right? Okay. All right, so that is it for chapter 12 lessons. In our next session, we will review for our final test of the year, chapter 12 review. So until then, may the numbers always be in your favor.